Welcome to this video on top 25 most asked C programming interview questions and answers. C programming is known for its simplicity, high efficiency and control over hardware, making it one of the most powerful and versatile languages. Its close relation to machine-level language allows developers exceptional control over memory and performance, which is why many MNCs still prefer C for system-level programming. C is typically the first language we learn in college, laying a strong foundation for computer science students. As a result, interview questions often revolve around C programming, making it crucial to master for both academic success and professional growth. So after understanding how important C interview questions are, I went ahead and studied hundreds of interviews that our Intellipaat learners had appeared for. And I found out some set of hot questions that recruiters often throw at the candidates. So guys, make sure that you're keeping your notebooks and pen handy to make the notes and get ready to ace the interview questions around the C concept. Let's look at the very first question.
So starting up with the very first question, which is what are the features of C programming language? So the C programming language is known for its simplicity and versatility. It's a procedural language, meaning it follows step-by-step approach to solving a problem. And C is also known for being fast and efficient, making it ideal for system-level programming. So talking about the more feature, which is portability, middle-level language, libraries with rich functions, fast and efficient, modularity, statically typed, general-purpose language, and rich set of built-in operation. So libraries with rich functions saves time by offering pre-built utilities, and as a middle-level language, C bridges the gap between low-level hardware and high-level programming language. So moving ahead with our next question, which is why is C called a middle-level programming language? So C is called a middle-level programming language because it blends features of both low-level language and high-level programming language. On the low-level side, it supports direct hardware interaction through pointers and memory management, making it close to assembly language. On the other side, high-level side, it offers features like function, control structure as in loops and if-else statement, and a machine-independent nature, which makes it very easier to understand and write. So when you write a C program, it gets converted into assembly code, showing its low-level capabilities, while retaining the readability and portability of high-level languages. And it is also used for system-level and general-purpose application. So moving ahead with our next question, which is, what are the basic data types supported in C? So C supports different type of data type to help you store different kind of values in variable. These are grouped into three types: primitive data type, derived data type, and user-defined data type. So in primitive data type, we have the most basic data type that are used for representing simple values such as int, float, character. So int for like whole numbers, example 5, 10, character for single character like A to Z, any character in between. Similarly, float for like decimal values, double and void. Coming to derived data type, so the data types that are derived from the primitive or built-in data type that are referred to as derived data type, like arrays, pointers or functions. Coming to user-defined data type, we have created by programmers for specific needs. For example, structures, union or enum. In C++, you have this class. So choosing the right data type ensures your programming uses the memory efficient and work correctly. So moving ahead with our next question, which is what are the tokens in C? So in C, a token is like a building block of a program. It's like the smallest meaningful element that C compiler understands. So you can think of it like a alphabet or grammar of the C language, which help you write and structure your code. So you see the different type of tokens present in C are keywords, operators, identifiers, constants, strings, and special symbols. So keyword meaning reserved word with specific meaning. For example, int, return, okay. And operators you all know like plus, double equals to or triple equals to. So in identifiers, names you create for variable function, example age or calculate sum, any variable which you name. So in constant, value that doesn't change. For example, pi value which is 3.14, it never changes. In string, you have a sequence of character enclosed in double quotes. For example, here, hello. Okay. Then we have special symbols like the parenthesis or curly brackets. So these tokens work together to create a meaningful and executable C program. Moving ahead with our next question, which is what do you mean by scope of a variable? In C, the scope of variable refers to the region or block of the program where the variable can be accessed and used. Okay, and once a variable is declared, it's only visible within the specific scope and you cannot use it outside of that scope. Okay, so we have two types of scope, global and local. So what are global scope? In global scope, the variable is accessible throughout the program. Okay, for example, if I declare int a equals to 20 here, okay, and I'm writing a function fun, which is taking some parameter, and I'm defining a variable int x equals to 10 here. So this a is your global scope and this x is your function scope, because this is only accessible inside the function. So the key pointer we have is a variable is only visible within the scope. Okay, global variable are accessed everywhere and local variable are limited to function or the block they are declared in. So that's all for this question. Moving ahead with the next question, which is, what is the use of header file in C? Okay, so in C, header files are like the toolkit that provide ready-made function and features you can use in your program. So they contain standard libraries like data type, useful macros, which saves your time from having to write everything from scratch. You can include header file in your program using #include. So whenever you start writing a C program, the very first step is that you include header files. So we include #include stdioh, which is a standard header file in system directory. Okay, whenever we want to use math, so we include #math. So this is the user-defined data type which are present in the source file directory. So in short, what we can say that header file help you make program easier, shorter and more readable. By providing built-in code and function you can reuse across different part of your program. So moving ahead with our next question, what is the difference between malloc and calloc in C? So in C, both malloc and calloc are used for memory allocation, right? But they differ in how they allocate and initialize the memory. So talking about the malloc, it allocates a specific amount of memory in bytes, right? The allocated memory is not initialized, it contains some garbage value. So talking about the syntax, we have a pointer with malloc size in bytes, okay? So suppose if we want to allocate a memory for 5 integers, so what we can do here is, we can create a simple int array with malloc function, okay, and then 5 into size of int, and we all know that size of int is 4 byte, so it will reserve the memory for 20 blocks, okay. So it only takes one argument and it does not initialize the memory to 0. The very major difference between malloc and calloc is this. And it does not add any extra memory overhead. So coming to calloc, so calloc we can also say that continuous allocation is there. It allocates memory for an array of element and initializes all the element to 0, okay. And it takes two arguments. Firstly the number of elements and second the size of each element. So coming to this calloc syntax, so we have ptr equals to calloc, okay, then number of elements, comma, size of elements, okay. For example, int array equals to calloc, then we want 5 elements and then size of int, okay. So it allocates memory for 5 integers and it is all initialized to 0 at the very first place. It initializes the memory to 0 and it adds some extra memory overhead. Okay, so moving ahead with our next question, which is, what are static variable and their uses? So static variable in C preserve their value even after they go out of scope, unlike regular variable, and they are initialized only once and retain the value across multiple function calls. For example, a static variable in function will keep track of how many times the function has been called. Okay, so taking a very simple example, if we have a count variable, which is common to all the three objects we have created, object 1, object 2 and object 3. Okay, so if we are incrementing the value of count for object 1. Okay, so suppose 100 plus 1. So what it will do, so whenever count for second object will be called, the count value will be 101 and not 100. So this is the beauty of the static variable. And again, if you increment 1, the counter will become 102, and when it will be passed to object 3 and object 3 will call this count, the value will be 102, not 100. Okay. So every time the count is called, the count keeps its previous value. In contrast, a regular variable inside a function resets every time the function is called. And remember that the static variable are stored in the data segment of the memory, not the stack, and are always initialized to 0 by default. So that's all for the static variable. Moving ahead with our next question, which is, what is a dangling pointer? So a dangling pointer in C is a pointer that refers to a memory that has been freed or is no longer valid. And this occurs when a pointer isn't updated after the memory it points is deallocated or goes out of the scope. So accessing such pointers can lead to crashes or unpredictable program behavior. So you can see here, this is the pointer 1 which is pointing to object 1. This is the pointer 2 pointing to object 1, and this is a pointer 3 which is pointing to something which has been already deleted. The scope is no longer active. So in this scenario, this is called the dangling pointer. So what are the common causes for this? Memory deallocation. So whenever memory is freed using free, the pointer still holds the old address, making it dangling, and assigning null to the pointer fixes this issue. So moving ahead with our next question, which is, what is the difference between local and global variable in C? So local variable is declared inside the function or block. As we already discussed, the function scope and the global scope. Okay. So it is declared inside a function or a block and is accessible only within that function or block. And what do we mean by global variable is that it is declared outside any function and is easily accessible throughout the program. So talking about the local variable, it exists only during the execution of the function or block. And global, it exists for the entire duration of the program. And what's the default value? So the local contains the garbage value if it is not initialized, and global, it automatically initializes to 0. And talking about the uses, we use local variable to store the temporary data specific to a function. For example, you can see here the code here on the screen. We have int x equals to 10 outside the function, which can be accessed by any other functions also. Okay, so if we have int solve here, okay, so we can easily access this x inside it. Okay, but if we want to access this y inside of this solve, we can't because it is a global variable. So that's all for this question. So moving ahead with our next question, which is differentiate between call by value and call by reference. So in C, call by value and call by reference are two methods for passing parameters to function, and they work differently. Okay, so coming to call by value, here only the value of the variable is passed, meaning it passes a copy and the original value remains unchanged. It's like giving someone a photocopy of a document and changes made to that copy don't impact the original document, right? Now coming to the code, if we have a function void swap, okay, it takes two parameters, int x and int y, right? And we have int temp equals to x, x equals to y, and y equals to temp. Okay, so what it does, the original value remains unchanged after the function call. Okay, and if we call this swap function here by passing suppose 10 and 20, so the original value will be remain unchanged, meaning whatever we are reversing the value in this function, 20 and 10 will not reflect outside the function. Talking about call by reference, in call by reference, the memory address of the variable is passed. Okay, the address is passed and original value changes. So it's like giving someone the original document to edit, and all the changes in that edited document will reflect in the original document. So taking the same example, if we pass here the references int x, int cross y. So here the original values will be modified. Then after the swapping will be have 20 and 10. So original value in call by reference is modified, but in call by value it is not. Okay, so that's all for this question. Moving ahead with our next question, which we have is, what is typecasting and how does it differ from the type conversion? So typecasting and type conversion are the method of changing one data type into another, but they work differently. So typecasting is a manual process where programmer uses a casting operator, okay, like target data type to change a data type. For example, converting a float to a byte. For example, repeat. So we have here float x and byte y. So we want to convert this float into byte. What we will do will be simply writing y equals to byte of x, and this parenthesis is called as typecasting operator. This is also called narrowing conversion and requires caution to avoid the data loss. Now coming back to type conversion, on the other hand, happens automatically by compiler during the compilation. For example, we have int x equals to 30 and we have float y. And if we want to convert the type of x, we'll directly write y equals to x, which will convert the value as 30.000. In short, we can say that typecasting is manual and flexible, but is riskier, while the type conversion is automatic, safer, and but limited to specific cases. So moving ahead with the next question, which is differentiate between a compiler and interpreter. A compiler and interpreter both convert the high-level language into machine code, but they work differently. A compiler translates the entire code at once. Okay, so here you can see that this call by reference, we have called this 4 times, and using compiler, this all is being executed at once. So it checks error during compilation and run faster, since the program is being run at once. However, an interpreter on the other hand translate and execute the code line by line. It's slower since it does not pre-translate, but it's easier to debug and more flexible, and the code is checked line by line. So you see, this is the first part, this is the second. So at this part also, it will go and check this call by reference statement, and if it is correct, then only the rest of the code will move. So moving ahead with explain the difference between macros and function. So macros are handled by preprocessor before compilation. They work by replacing the macro name with its value, which increases code length. Since the macro does not undergo type checking, error can go unnoticed until runtime. So you see, if we want to print the number, we have to define here the number. So macros are the preprocessor directive that expand the code at compile time only, whereas the functions are the block of code executed at runtime with type checking. So here you can see we have this function which is returning 10, and here the output statement. So we can say that function maintain code length regardless of their uses as the control transfer during the runtime rather than copying the code, while their execution speed may slower down due to the overhead of function call. So in short, function ensure the safety with compile time error checks and are more reliable for structured programming. So moving ahead with our next question, which is what is recursion and where is it used? So recursion is a process where a function calls itself either directly or through another function. So you can think of it as breaking a bigger problem into smaller one, a similar problem until you reach a simple solution. For instance, finding a factorial of a number. Fine. For finding the factorial of 5, what you will do? You will call factorial of 4, then factorial of 3, and then so on until it hits the base case, which is factorial 1. What's the application? So it shines in solving the problem that involve repetitive smaller tasks. For example, in data structure, graphics, AI, etc. In maths, we can say finding factorial, Fibonacci numbers, or solving Tower of Hanoi. In data structure, traversing the tree or graph, the height and like top view, right view of the tree. In computer graphic, generating fractals. So for example, you see we have this recursion function which is taking x as parameter. Okay, this is the base case that if x at any point of time becomes 0, then return. Okay, if not, then recursion x minus 1 is being called. For example, if here we are taking 5, then we are checking if 5 is equals to 0, no. If it's not 0, then recursion function will call for 1. 5 minus 1, which is 4. Okay, so function is being called again by itself. Okay, that's all for the recursion. Moving ahead with the next question, which is what is dynamic memory allocation, and mention its syntax. So dynamic memory allocation in C refers to the process of allocating the memory at runtime, allowing the size of data structure like arrays to change dynamically. It provides flexibility and helps optimize memory uses. So what are the key points? We have fixed size array in C which cannot adapt to change memory during the runtime. Okay, so the key point here is that fixed size array in C, it cannot adapt to changing memory needs during the runtime. So dynamic memory allocation enables the resizing of an array or data structure to save memory accommodation of additional data, and it is achieved by using the function provided in standard library. So the function for dynamic allocation are malloc, calloc and free. Okay, so talking about malloc, it allocates a block of memory but doesn't initialize it. Okay, so here it's allocating 20 bytes of memory which is dynamically allocated to PTR by using this malloc function. Okay, talking about calloc, it allocates memory and initializes all the blocks to 0. Okay, so here you can see it's allocating this calloc function 20 bytes of memory and initializing all the blocks at 0. Okay, now talking about free. So free allocate memory to prevent memory leaks. For example, this calloc, its 5 blocks of 4 byte each is dynamically allocated. An operation on PTR is performed, and after the operation is performed, the memory is released. So dynamic memory allocation is essential for efficient memory management in C programming. So moving ahead with the next question, which is write a C program to swap two numbers without using a third variable. Okay, so let's see the code for this. So you see, here is the code. We have the main, we have two variables A and B and a print statement for entering the numbers. Then the print statement before swapping A and B. So what the logic is? Logic is firstly, we'll add the two values and we'll subtract B from the sum to get A. Okay, and then subtract the new B from the sum to get B. So let's run this code. So it's asking enter two numbers. Okay, so let's say 12 and 13. So before swapping, the value of A is 12 and B is 13, but after swapping, the value of A become 13 and B is 12. So we can say that we can swap two numbers using addition and subtraction to interchange the values. And we can also use swap function also, which is a predefined function in C libraries. So moving ahead with our next question, which is what is the use of printf and scanf in C? So the printf and scanf functions are essential for input and output operation in C programming, and both are the part of standard library. So printf is used to display the inserted data on the console after the program. For example, if you want output of anything, you just use printf. Coming to scanf, which is used to take input from the user via console. It also uses format specifier to read specific data type and store the input variable. For example, scanf %number. What it will do, it will read the integer and store it into number. So the syntax for scanf is scanf %d, okay, comma number. Okay, talking about printf. So printf is, this is number. This will be print out on the console and this will be taken input from console. Moving ahead with the next question, which is write a program to check whether the string is palindrome or not. Okay. So what do we mean by palindromic string is, suppose we have this string ABCD CBA, and after reversing we have ABCD CBA. So after reversal both the strings are same. For example, suppose we have a word act. After reversing we will have TAC. So both the strings are not similar, that means it's not a palindromic string. So what's the logic? We'll reverse the string and compare it with the original string. And what function we'll use? We'll use string comparison, string reversal and string copy. So let's see its code. So this is the program to check whether a string is palindrome or not. We have two variables, string and reverse. We are taking input string from user in str, and then we are copying the string here. We are copying this original string str into reverse, and we are reversing it. And we are checking with this string comparison function, we are checking the original and reverse string. If it is 0, if it is true, then the string is palindrome, otherwise the string is not palindrome. So we'll run this code. So suppose we entered aka. So see, this is saying that this string is palindrome, because after reversal also this will give the original value. So this was the code for checking a palindromic string. So we'll move ahead with our next question, which is write a program to check whether a number is prime or not. So what's the logic? We'll check divisors from 2 to n by 2n, and if it is divisible, it's not prime. So a condition will be a number greater than 1, divisible only by 1 and itself for a prime number. So what variable we are going to take in our program? Input and is prime. This is the code. We have this number n which will take from user. We have I, the iterator, and is boolean which we have initialized it with 1. So we are taking this number. So we are checking here this condition. If the number the user gave is less than or equals to 1, it's not prime number. And then we will check the divisors from 2 to n by 2. In a loop we are checking, and if the number which we got input, if it is divisible by I and is equivalent to 0, then it's not a prime number, and we'll change this flag to 0 and will break. So, and if this is prime is true, we'll print that number is prime, otherwise the number is not prime. We'll run this code. Okay, enter a number, say 4. We all know that 4 is not a prime number. So yes, 4 is not a prime number. But again, we see for 7. So enter a number, for example, 7. So you see 7 is a prime number. So moving ahead with our next question. Write a C program to reverse a string. Okay, so what is the logic? We'll accept a string from user. We'll find the length of that string using a loop, and then we'll reverse it and print the character in reverse order using a loop. So we'll see the code for the same. In this code, what we are doing, we have this string str, we have this iterator I and length 0. So we are taking input string from user and finding the length of that string, okay, by using while loop. And then what we are doing, we are printing the reverse string by iterating the whole string from the end. So we will be initializing I equals to length minus 1, meaning we will be starting this from the end. And I is greater than equals to 0, I minus minus, and then we'll be printing the string, each character of the string. So let's run this code. Okay, for example, I want to reverse the string elephant. So you see the reverse string is this one. Moving ahead with our next question. Write a program to generate random numbers in C. So what's the flow we are going to follow here is, we'll take input, which user will specify the number of random numbers he or she wants to generate, then a random generator, okay, and then output. So we'll see the code. So you see, we are taking here the number of random numbers want to generate, then we'll fix the random generate with a fixed value, okay, and then we'll generate using this rand function. So we'll run this program. Okay, yes, so how many random numbers you want? Say for example, we want 4 random numbers, okay. So you see, it provided the random numbers as 41, 18, 467, etc. So that's all for this question. So moving ahead with our next question, which is, what is the difference between static and dynamic memory allocation? So static and dynamic memory allocation refers to how memory is assigned and managed during a program's execution. So in static memory allocation, the variable gets allocated permanently till the program executes or function call finishes. But in dynamic memory allocation, the memory is controlled by the programmer and it's get allocated whenever a malloc or a calloc function is executed. Talking about the second pointer we have the static memory allocation is done before the program execution. Fine. But whenever you are dynamically allocating the memory, it's done during the program execution. In static memory allocation, it uses the stack for managing the static allocation. But it uses the heap. The dynamic one uses the heap. Of course, it is less efficient because we don't know how much memory is required during the runtime, and what if we allocate more than what's required. On the other hand, DMA is more efficient. In static allocation, there is no memory reusability, yes, but in dynamic memory allocation, there is a reusability. In static allocation, once the memory is allocated, the memory size we can't change. But here we can change the memory size once the memory is allocated. Okay, moving ahead with the next question, which is write a program to check a Armstrong number. So, what's the Armstrong number? Suppose we have this number 153. It's having 3 digits, right? 1, 5 and 3. So, when we are cubing the number, for example, 1's cube is 1, 5's cube is 125 and 3's cube is 27. So, if we'll sum up this number, we'll get 153. Suppose 4 digit, then 1 to the power 4, 6 to the power 4, 3 to the power 4 and 4 to the power 4. The ladder will get 1634. So, what's the logic? We'll count the digit, then calculate the sum and compare it with the original number. Okay. So, here's the code. What we are doing, we are defining 4 variable num, original num, remainder and result. We are taking an integer, storing it in num. Then we are initializing original num to num so that we don't lose the track of the number, original number. Then we are finding the digits. Okay. We are here finding the digits. Then we are calculating the sum of each digit raised to the power of n. And then in the end, we are checking if the number is Armstrong. So if the result is equals to the original number which we have stored in num, if it's true, then the number is Armstrong. Okay, let's run it. So here enter an integer, for example, 153. So let's run this code. Okay, and enter integer, suppose 12. So you see that 12 is not an Armstrong number. Okay. So moving ahead with our last question is, what is a preprocessor? So preprocessor is a software program that processes a source file before sending it to be compiled. So inclusion of header files, macro expansion, conditional compilation and line control are all possible with preprocessor. Okay. So you see, this is a C program source code, then comes the preprocessor, then comes the compiler and then linker. This all compiles into a executable program code. So that's all from my side. If you have liked the video, kindly hit both the like and subscribe button for Intellipaat's YouTube channel. See you in the next video.